Good evening, everyone, and very warm welcome to today's masterclass titled Internet of Things Through the Lens of Computing and Data Science. The masterclass is organized by Sai University School of Computing and Data Science, and it's my pleasure to introduce our distinguished speaker for today, Dr. Ashok Chandrasekaran. Dr. Ashok brings nearly a decade of teaching and research experience in the field of signal processing, the special focus on array signal processing for radar systems and emerging 6G wireless technologies. He has worked on prestigious research projects at institutes like Central Electronics Engineering Research Institute, CERI, where he contributed to the development of machine vision system, and also in IIT Bhubaneswar, where he was involved in direction of arrival estimation research as well. Dr. Chandrasekaran has published widely in reputed platforms such as IEEE, Springer, Elsevier, and Peer, and was honored with the IEEE Publication Award in 2021 by the IEEE Madras section for his innovative work on machine learning inspired DOI estimation as well. He also holds a published Indian patent in the domain of passive radar applications. In addition to this, Dr. Chandrasekaran actively contributes to the academic community as a peer reviewer for leading journals, including the IEEE Transactions on Vehicular Technology, IEEE Sensors Journal, and several Elsevier and Hindawi publications. We're very delighted to welcome you for today's masterclass, sir, as a speaker, and over to you.
Thank you, Mr. Nelly. Thank you for introducing me. Let me share my screen. Is my voice is audible?
Yes, sir, loud and
Uh,
clear.
yeah. Okay.
Uh, and one more thing, participants. So if you have if you want to speak up, you can raise your hand. We'll enable you to talk. Or if you have anything to share with sir, probably you can use the chat box available or the Q&A section available as well. Yeah. Sorry, sir. Over to you. Yeah.
Thank you. Thank you, Mr. Nelly. Good afternoon, everyone. So, the topic of my talk today is Internet of Things. So, let us look at the IoT technology through the lens of computing and data science. So, here is my outline. So, first, we will see what is IoT, right, and why it matters. Next, we will briefly look at the history of IoT. Then we will discuss the potential of IoT through a simple cost calculation. So I hope you will enjoy it. And then we will discuss the core components of IoT. And after that, we will discuss the key technologies in IoT from a computer science and data science perspective. Finally, I will introduce niche domains in IoT technology, such as Internet of Military Things and Internet of Underwater Things. So these are all the topics we are primarily focused in this talk. Okay, so with this outline, so let us start with what is IoT. So probably most of you might have heard about this technology IoT, and so let us look at in a different perspective. So before that, I just want to check, Mr. Nelle, am I audible? Is my voice is clear?
Yes, sir. You are. Yes, yes.
Thank you, Mr. So let us look at what the internet says about IoT. Okay, so let us start with what Wikipedia says about IoT. So according to Wikipedia, IoT is a system of mechanical and digital machines with UID. So here this UID refers to unique ID and the ability to transfer data over a network without requiring human to human or human to computer interaction. Okay. So let us look at one more definition. So according to Cambridge Dictionary, IoT is objects with computing devices in them that are able to connect to each other and exchange data using the internet. Okay. So let us understand. So if you carefully look at both the definitions or statement, so in simple terms, these definitions mean IoT is basically a device or a system with computing capability. It can identify themselves, connect to a network, and able to share information automatically. So this is what both the definition try to convey. uh, about IoT. So let us understand IoT better through some more definitions. So anyway, I'm not going to read through all the definitions. So there is an interesting slide coming up. So where we will try to redefine the term IoT in simple words. But kindly bear. Um, Let us look at what analyst definition of IoT. So for example, EY. Most of you might have heard about this company. So Ernst and Young is one of the largest professional accounting firm. So let us look at what EY says about IoT. Internet of Things describes the connection of devices, any devices, to the internet using embedded software and sensors to communicate, collect, and exchange data with one another. Okay, so let us quickly run through all this definition. So if you look at networks engineers definition of IoT, for example, the Internet Engineering Task Force, let me slightly brief about what is this IETF. So it is basically a professional society that develops and maintains internet standards and protocols. And obviously, you know about Cisco, right? Cisco is best known for internet infrastructure products and networking. It's a multinational company. And about IEEE, that is Institute of Electrical and Electronics Engineers, best known for technical standards. Say, for example, Wi-Fi standards, if you take 802.11. So IEEE is responsible for, setting up technical standards for wireless technology, even for electrical and electronics related technologies. So if you carefully look at all these definitions, they all convey the same meaning, more or less. Like IoT is basically objects or devices with computing capability and that can talk among themselves, which means they can exchange data among themselves. So that is what primarily all these definitions are trying to convey, right? So these are all the existing definitions available. Even if you type in Google, you can get all these details. Now, with this note, let us try to redefine the term IoT in simple terms. So, yeah, let me reveal that. In simple terms, IoT is basically connecting things to the internet. So, things mean objects, edge devices, but there are certain characteristics a thing should possess. So, those characteristics are basically, the thing should be able to sense, process, connect to a network, and act on the processed information. These are all some of the characteristics of things uh, in the context of IoT. You can recognize numerous applications ranging from wearable technologies, smart vehicles, smart homes, and many more applications which you can easily think of or easily recognize in the context of IoT. I have a question here. So why would we want to connect things to internet? So we understood that Internet of Things is basically connecting things to the internet, and just we discussed that there are certain characteristics stitched to things. Now the question is, why would we want to connect things to internet? Right? The question is very simple and straightforward. So the answer is very simple. So if we connect things to internet, then things can exchange information, exchange data. But how does it matter? That is the second question which you can ask towards IoT. So it makes the thing smart, right? That is the reason why. So we always connect devices, nodes to internet to, to make it smart. We will understand what is smart in the forthcoming slides. Let us try to understand what is IoT first. So let me provide the foundation and then slowly we will get into the details. So there is a note for your information. The storage or processing capability alone does not make a thing smart. right? So ability to connect actually makes it smart about the thing I'm telling, right? So anything should possess certain characteristics, then only we can call that as the Internet of Things. So I think so you can get the essence of IoT. Now let us briefly look at the history of IoT. Here is an interesting fact actually comes in. So the foundation for IoT is RFID, that is radio frequency identification. So there is an interesting fact attached to it. So this RFID, that is radio frequency identification, which was originally developed during World War II in the 1940s, and later it got commercialized in 1970s. But this is the foundation for this technology called IoT. And most of you might familiar with RFID technology. RFID is basically a technology that uses electromagnetic fields to automatically identify and track tags attached to the objects. So you can find it in applications such as access control, punch card systems, and inventory management, logistics, or suppose in your school or in colleges you can see a smart library with the RFID tag, right? So there are a number of applications which you can think of with respect to RFID, but please understand this is a foundation for this technology, that is IoT. Okay. So this is a small, history of IoT. Let us not get into the details much. Now, just a second. Yeah. Now let us look at the potential of IoT. So through an simple application, smart retail. I think most of you might familiar with smart retail application. So specifically, we will take one scenario, that is footprint tracking in retail shop, basically a smart retail shop. So let us do a cost comparison and we will see the potential through that. So that is what the primary idea here. So let me first explain what is footprint tracking and then we will get into this cost calculation. So footprint tracking is basically about counting how many customers actually come in and how many customers you know visit certain shelves and how much time they spend on different spots. So this is what basically the footprint tracking in retail shop. So don't look at the third column. So that is with IoT technology or IoT solution. Suppose if we want to track a footprint of customers in a retail shop, then to collect data about how many customers actually walk inside the retail shop and how many of them visited the good product shelves and all that. So for that, definitely we need some data to analyze. So for that, the retail shop need to employ some staff members. So let us take a simple case. If staff manually observes the customers for 2 hours per day, this is just an example. So 2 hours per day, and if the salary for the staff per hour, if it is 100 rupees, then 30 days, it is going to be around 6,000 per month. And per year, if you see, it is going to be 72,000, right? And here, missed sales, I mean, that's basically the poor shelf placements. Because if we involve staff, especially for manual observations, there is a high chance for poor shelf placement, right? So let us take that sales, lost sales as 50,000 per month, and per year it is going to be 6 lakh. And again, you don't need to worry about this. We don't need to worry about the IoT hardware cost for this solution, like because it is a manually staffs are going to observe it and they're going to make a data. Okay, now in contrast to that, suppose if we deploy a IoT solution, then in what way that benefits? Let us look at it. So we can collect the data, right? The footprint tracking data using IoT sensors. So we can use some heat map camera so that can automatically track customer movement in the retail shop. So anyway, there is a hardware cost and software cost involved in it. So I have that down. And there is no cost for staff to physically monitor. And so with this IoT technologies, we can, you know, properly place some good products at good spots. So let me take a extra sales gain as 30,000 per month. That's just a rough number. So then it will become 3,60,000 per year. And the IoT hardware cost, it is one-time investment. Let us take it as 90,000, and IoT software cost. So if it is a subscription based or otherwise a renewal based, let us take 24,000 per year. Then if you look at the total annual benefit for the IoT solution, especially for this case, anyway we are saving that 72,000, the labor cost plus the missed sales gain, that is 3,60,000. That is basically the extra sales, and we need to subtract the hardware cost and software cost. So let us subtract the software cost, that is 24,000. So we can save 4 lakh, or we will, the shopkeeper will get, the retail shop owner will get 4 lakh 80,000 per year as a amount. Okay, what about the hardware cost? So that can be recovered in 3 months, because 90,000 roughly if you divide by 3, so right, so we can recover that 90,000 in 3 months of time. So after that, it is going to be pure profit. So it is going to be 34,000 per month. So, roughly around 4 lakhs per year. So this will clearly show us the potential of IoT technology. Yeah, it involves lots of components. Anyway, we will see those components in forthcoming slides. But you just imagine a situation about this footprint tracking, and just carefully look at this table. You can literally see the potential of IoT in terms of cost, how it benefits in terms of finance or cost, right? So 4 lakh per year. And moreover, we will get some extra sales gain, right? So, through this, easily you can understand the potential of IoT. Just a second. Yeah. So now let us look at the core components of IoT, or core components that makes up an IoT system. I think most of you might familiar with all this terminologies, but let us look at all that in a, you know IoT framework. So sensors. So the purpose of sensors are basically, to sense the information or to collect the data from the environment. So here I have shown some set of sensors like temperature sensor, proximity sensor, smoke sensor, right? There are so many sensors shown here. So the purpose of sensor is basically to collect the data from the environment. So the second core component of IoT is processor. So why we need processor, right? Processor is basically a hardware, physical device, and it is going to process, basically going to analyze the collected information from sensor, and it is going to decide what to do on that. So I can show you, I have a single board computer with me. So this is not a general computer. This is a single board computer. So here you can see the ESP232. This is basically a processor. So this is a single board computer. This can act like a computer, and inside the processor is there, and that is basically the ESP32. So processor, in the sense, it is basically a microcontroller. So you can think of how small it is. So you can easily, I think, figure out how small it is. So that is what I depicted here. That is what I shown here. So processor, the basically it is going to process the data collected from the sensors, and it is going to take some decisions out of it. So that is what the purpose of processor. Then one more key component in IoT is communication technologies. So see, we have sensors, we have processors. We need some communication technologies to send and receive data between sensors and processor, or between two edge devices, or between edge and cloud. There are lots of technologies. Anyway, we will look at all the key technologies in forthcoming slides. Just to give a flavor that what are all the core components of IoT, so I made this slide. So communication technologies is one of the key ingredient of IoT, which helps us to send, receive data between devices, nodes, or between edge and cloud. And the last core component of IoT is actuators. So here you can see I have shown some, actuators here. So let us understand what is actuators. So after processing the data by the processor, we need to perform certain actions, certain physical actions, like to turn on or turn off a bulb, or to turn on or turn off a valve, right? So these are all basically the actuators. Actuators means, so we are going to act on the processed data. That's why it is referred as actuators by performing a physical action. So you can see here servo motors, linear actuators, electromagnetic actuators, and solenoid valves. These are all the actuators. So these are all the four ingredients or core components of IoT: sensors, processor, communication technologies, and actuators. So now you can easily reinforce this with the definition. So I told you initially that IoT is basically connecting things to the internet. But if you look at the detailed definitions, so IoT is basically the devices equipped with computing capability that is possible with the help of processor, and so that can sense, you know, connect to a network and act on it, right? So now you can easily reinforce all these core components with the definition. I hope so. So this is all about the core components of IoT. Now let us look at the key technologies and in IoT. So if you have any questions, you can stop me at any point and you can ask. Is it clear for everyone? Okay, let me proceed. So key technologies in IoT. Let us look at the key technologies in IoT from a computer science perspective first, and then we will look at data science perspective. So there are three broad classes of computing. One is edge and fog, and another one is cloud. So let us understand what is edge, what is cloud, and fog. So edge is basically a computing approach. Usually, computing happens on the device, at the edge, at the source itself, the computation will happen. So meaning if there is a sensor or if there is a, small processor, right? The ESP32, for example. So the computation will happen there itself. So at the source, if you perform any computation on the source itself, then that is usually referred as edge computing. It's basically a local data processing, especially for real-time decision making. And yeah, as I told you, right, edge devices are basically the microcontrollers, single board computers. As I said, no, this is basically a single board computer. This is not Raspberry Pi. This is a dedicated board designed for IoT applications, because the core here is microcontroller, that is ESP 32. And cloud computing, yeah, so the computation happens not at the source. It is going to happen at uh, you know centralized data centers. It is going to be far away from the source. Suppose if I have a sensor here and I'm going to do the computations somewhere far away from my source. So usually we use AWS and some facilities we use it for cloud computing, because we generally run heavy algorithms there to get some useful result out of it. So then what is fog computing? So fog computing is in between edge and cloud. It's kind of a mini server, or I would say gateway. So where we can do certain computations. So depending upon the requirement and application, we need to choose the computing approaches. So edge computing may be a suitable candidate for one application, and cloud may be a suitable candidate for different applications. So we cannot generalize anything here. We cannot fix, uh, so we cannot generalize it. That is what. So for your information, just to understand this computing better, I think most of you have heard about machine learning, right? So we can run conventional machine learning in cloud as well as in fog to some extent, that is in local servers or otherwise a local gateway, but not in edge devices. You cannot run huge machine learning algorithms or conventional machine learning models in this single board computer. So then what is the solution? So the solution is TinyML. So there is a significant and growing research interest in this domain, TinyML, that is tiny machine learning. It is basically an intersection of machine learning and embedded systems. So these algorithms are lightweight algorithms. So these algorithms can run in edge devices. Edge devices, I mean, so this can be considered as an edge device, and in this device we can run the machine learning models. Basically, that is TinyML. Whereas in your computing system, in your general purpose computing systems like your laptop or even desktops or in cloud, you can run the conventional machine learning models. The reason is very simple because this is a battery operated device, and moreover, the RAM size. Anyway, I'm not going to get into the details, but if you look at the RAM size and ROM size, everything is going to be small, right? We cannot compare this single board computer with the general computing machines. That's the reason why we need a lighter version of machine learning models to operate on edge devices. There is a significant research going on in this direction, so you can explore about it. TinyML. Okay, so next let us see one more technology in IoT, that is communication technologies. So already I briefed about the importance of communication technologies in IoT. Now, there are two broad classes. One is the short range communication and long range communication. So, in IoT framework, we generally don't use Bluetooth. Instead, we use BLE, that is Bluetooth with low energy. So, you can understand the technology with respect to data rate and range and power consumption here. So, if you look at Wi-Fi, so Wi-Fi is best suited for short range communication, not for long range communication, and RFID. And even if you look at Zigbee protocol, so Zigbee is basically a communication technology that is designed to operate at short range with low power consumption. It is not going to drain your battery, but at the expense of low data rate, right? This is suitable only for low data rate applications. Suppose we cannot use Bluetooth, Wi-Fi, and Zigbee for long-range communications. So we need to use LoRaWAN. There are some dedicated communication technologies available that we need to use it for long-range communication. So here you can see LoRa, narrowband IoT, and LTE-M, right? So for smart cities and smart agriculture, LoRaWAN is widely used, and narrowband IoT is used. That particular technology is used for smart metering and cellular communication technologies like 5G and beyond, that is basically the 6G. So that is widely used for autonomous vehicle and remote surgery, right? So if you carefully look at the cellular technology, that is LTE and 5G or beyond, the 6G, so you can get a high data rate. So if you use 5G, you can get a high data rate, but we cannot reach, you know, a long range communication. So for mid range communication, cellular technologies are fine. But if you look at the other side, so it is going to consume a lot of power. So that's why you see here the 5G, especially the cellular communication cluster, is going to take a lot of power. So generally in IoT, we for short range communications, we prefer to use BLE, Wi-Fi, Zigbee. For long range, we prefer to use LoRaWAN widely and narrowband IoT. If there is a requirement, we use cellular technologies like 6G and beyond, because it is going to drain a lot of battery power that you can easily uh, recognize or understand, because now everything is 5G, true 5G and 5G. So when you use 5G network, then it is going to drain your battery in a very faster rate. Okay. So I hope this picture will give you a very clear understanding towards the role of communication technologies in IoT, especially with respect to data rate and range and power consumption. So yeah, so now let us look at communication protocols. So what we have seen is communication technologies. Now let us look at the communication protocols. So before getting into this communication protocols, I just want to give a small idea about what is protocol in general from a computer science perspective. Computer science in the sense from a networking perspective. Let me take my single board computer, and this is basically the interface. So I can connect a physical interface to this. single board computer. So interface is basically a physical way through which we can share the data. But protocols are basically rules that is going to ensure whether devices understood the data that is being exchanged between the nodes. So protocols are basically the rules that ensure devices understand what they send and receive. That is what protocols is all about. Even though there is a physical connection exists between a single board computer and the edge device, we need protocols. We need some rules, right, to ensure whether the device can, understand the data that they send and receive. That is the purpose of protocols. So you have to understand carefully what is the key difference between communication technologies and protocols, because protocol is an important topic in computer science, especially in networking. So I think most of you might familiar with web browsing. So the application layer protocol used in web browsing, that is when you type www.google.com, that is basically a HTTP protocol. So HTTP in the sense it is going to work as client server model. Client server model. It is basically a request response model. Uh, Whereas in IoT, we don't use, yeah, in certain cases we use a request response model. But mostly, if you see, we prefer to use a dedicated protocol designed for IoT, that is MQTT and QAP. So these are all not request response model. These are all slightly different. So this MQTT application layer protocols and QAP are basically, you know, PubSub models. It is usually referred as PubSub in the sense publish and subscribe model. It is completely different from the client server model. So for you to understand, let me give you a simple example. So you can see a smart car here. So smart car can sense a lot of informations and that can be published to a broker. Broker means how you consider it is a server. So that may be a local server or maybe a remote server. It is basically going to be a server. So smart car is going to sense information and it is going to send the data to broker with the topic. You can see here, it is going to publish the sensor's data with a topic name radar, because this data is actually conceived through radar systems. And if you look at uh, here, so it is going to publish, it is going to send the ultrasonic data to broker with the topic ultrasonic. Now, client device can access the data from broker based on their subscription. So if the client is subscribed to radar data, then client can get the data from the broker. If the client subscribe to ultrasonic data based on the subscription, so client device can get the ultrasonic data from the broker. This is completely different from the HTTP protocol, because HTTP protocol is basically a request response model, but this one is a publish subscribe model. Okay, why we want to have this kind of a model in IoT framework? As I told, if you use typical or conventional application layer protocols, then that will drain a lot of energy, that will drain the battery power. So that's the reason why these protocols are designed for IoT framework. It is going to use less battery power, especially this publish and subscribe model is not going to take, much of the battery power. That's the reason why we prefer to use MQTT protocol and QAP protocol for IoT framework. And moreover, you can also add a security layer, right? You can add TLS to it, that is transport layer security. Then it is going to be MQTTS, which you can relate with HTTPS, that is hypertext transfer protocol, with TLS, that is transport layer security. So that you can easily, uh, recognize, that is HTTPS dot www dot some website dot com, right? So I told it is so this is useful, or this is more suitable for resource constrained devices. Resource constrained devices means the battery operated, small RAM size devices. So that's the reason why MQTT and QAP is widely used in IoT applications. Whereas for any web related applications, even in IoT framework, HTTP is used. Okay. So anyway, I'm not going to talk about Quack, and so this is what, right? Once the client subscribe to, broker with the topic, then broker will send the data. Broker is going to publish that particular data to the client device. So this is what the PubSub model is all about. Okay. Okay. Now let us look at the security aspects. So just to check, Mr. Nellai, is that everything fine?
Yes, sir.
Yeah.
You're clear. Yeah.
Thank you. Thank you. Thank you so
Yeah, and
much.
also one more thing, participants, if you have any questions in between, you can leave it in the chat box, so probably sir can answer, or you can raise your hand. We'll enable you to talk. If you have any doubts, so later also we'll get it out for you.
Yeah. Yeah.
Thank you.
Yes. So participants, if you have any questions, you can stop me at any point. You can unmute your mic and you can ask. Okay. So let me check the chat. Right. So let us look at the one more aspect in computer science from a computer science perspective, that is security. See, if you see, billions and billions of IoT devices are connected to internet now, right? As we know that, so we have good guys and bad guys in internet. So it is our responsibility to protect the data. So we cannot send any data as plain text on internet. So we need to protect our data. So how we are going to protect our data? So we need to protect our data with some cryptographic techniques. So that those things are encryption, authentication, authorization, and even we can use blockchain. So these are all some of the cryptographic techniques we can use. Not blockchain, the encryption, authentication, and authorization are basically the cryptographic techniques. So that we can use it to protect our data on internet, so that the man in the middle or attacker cannot access the uh, data. But the problem here is usually the cryptographic algorithms what we use for general computing system, especially in, let me move my screen. Yeah. So if you look at in servers and desktop, we prefer to use conventional cryptographic techniques. Tablets and smartphones also you can use the conventional cryptography, but we cannot use the conventional cryptographic techniques for IoT framework. The reason is all those cryptographic mechanisms, if you see, it is going to drain the battery very fast because all are complicated mathematical algorithms. And so that's the reason why we need a lighter version of cryptographic techniques for IoT applications. So that is basically the lightweight cryptography. There is a subclass in cryptography that is lightweight cryptography. So there is a huge scope for this lightweight cryptography. So already we have heavyweight conventional cryptographic techniques available. So what we need to do is we need to come up with a lighter version of it so that we can, you know, operate, or we can burn all that cryptographic algorithms inside a single board computer for uh, processing and to exchange data over the internet, basically. So that is what the resource constrained devices are, the devices that have limited resources. Limited resources, I mean, computation power, memory, and even the size, area, right? So this you imagine, this is a, I'm calling this as a single board computer. So this is, if you see the form factor, this is, it's very small compared to our general computing machines, laptop or even desktop, or let us take a big GPU based systems, right? So that's the reason why we need a lighter version of conventional cryptographic techniques. So there is a uh, huge interest and significant research is going on in this direction. So if you are interested, you can explore more about lightweight cryptography. So yeah, now let us look at one more interesting topic in computer science, that is operating systems. Let us look at operating systems in IoT framework. So we are familiar with operating systems like Windows, Linux, and Mac OS, and even Android. So we generally use this general purpose operating system. The moment you say operating system, that is a general purpose operating system. Windows, Linux. So the Windows, Linux can be used for general purpose computing tasks, the tasks that are not time critical, right? But whereas in IoT, the tasks are basically time critical. Say, for example, if you take a smart car, once the data is sensed by the millimeter radar, immediately the car need to take a decision, right? If there is a obstacle in front of the car. So all the tasks basically involved are time critical. So we cannot use the typical or general purpose computing operating systems in IoT framework. So that's the reason why in IoT framework we use RTOS, that is real-time operating system. That is totally different from operating systems. So, example, FreeRTOS. FreeRTOS is one which is generally used for IoT applications, whereas whereas for our general missions, general computing missions like laptop or desktop, we use Windows, Linux, and Mac OS. So the reason is very simple. So here, what we have is a resource constrained device where we don't care about the uh, power source, because you can use a power card to connect and charge, right? Whereas in, suppose if you deploy a node somewhere in the remote place, if there is no power source, that is going to be difficult, and even you don't get privilege of large RAM size or ROM size. So these are all the challenges with respect to IoT. That's the reason why we prefer to use real-time operating systems over operating system, that is basically the general purpose operating system. Okay. So anyway, I'm not going to get into the details about what is operating system and those things you will learn in operating system course. I just want to give the different technologies involved in IoT, which are related to the computer science. Okay. So these are all the aspects from a computer science perspective. I think so. We started with the core components of IoT, and then we discuss the computing approach, communication technologies, communication protocols, and security, right? And operating systems. Yeah. So based on the need or requirement, so we need to choose the approach, especially for communication technologies and the computing approach. Okay. So now let us briefly look at the key technologies in IoT from a data science perspective. So data science definitely has a major role in IoT because the data generated by the devices are huge actually. So it's a big data basically. So we need to process, we need to handle, manage all that data, all that big data. So there are tools available and technologies available through that we can handle the big data and we can perform certain analytics on that. And obviously, artificial intelligence and machine learning can be used for prediction, and for automations, we can use all that technologies such as neural networks, natural language processing. These are all some of the technologies which is predominantly used in IoT framework. And again, you can also use Tableau and Power BI. These are all the hardcore topics in data science. So that can be used for representation of representations and to get some data insights, right? So because the data generated out of this billions and billions of devices are very huge, right? So that's the reason why we need some technologies and techniques to analyze, manage, and process, to automate, and to make some predictions and to visualize all that data. So we need a platform and we need a dedicated stream, I would say. So data science has a major role in IoT. So yeah, you can actually explore more about this. And uh, yeah, so let us look at the final aspect of the today's talk, that is niche domains in IoT. So there are lots of domains in IoT, like Internet of Medical Things, but I just want to highlight niche domains in IoT. So that is Internet of Military Things or Internet of Battle Things. Okay. So integrating IoT in defense and military actually transform the modern warfare systems. So, okay, you can easily witness that. So if you look at 2025, the market size is 487 billion USD. So in rupees, it is going to be roughly around 4 lakh crore. 4 lakh crore. So that is a market size for Internet of Military Things 2025 2025. But if you look at, there is a exponentially increasing growth for this class, that is Internet of Military Things in IoT. So there are, okay, let me reveal the key areas of IoT, IoMT basically, that is Internet of Military Things. So wearable devices for soldiers, that is basically the connected soldiers. So that is basically used for real-time health monitoring, location tracking of soldiers, and heart monitoring. You can look at a picture here now. So this is basically a connected soldier project by the US Army, right? There is a huge interest for this, Internet of Military Things. So wearable devices for soldier is one key area, and the other areas are autonomous systems, especially for drones and UAVs, especially for surveillance, and smart bases. Smart bases are basically, the military base, especially there is a growing interest on how to secure the, access control, because these are all the sensitive zone, right? And how we can manage the resource and logistics. So for that also IoT is integrated, and there is a big interest for it. And predictive maintenance. So if you can deploy lots of sensors and you can do, predictive maintenance, especially to monitor the engine and equipment performances, because in warfare there are lots of equipments involved, starting from weapons to artillery vehicles, drones, right? So we can do predictive maintenance with the help of machine learning and deep learning mechanisms, integrating with this IoMT. And IoT equipped weapon system, there is a huge interest in this area as well. That is basically real time targeting and remote operations. We know where, it is basically the unmanned operations, or otherwise the unmanned vehicle equipped with some weapon systems. So these are all some of the key areas in Internet of Military Things. There is a growing interest in this area, and so you can pick certain problems from this uh, class and you can explore. So because there is, so if you look at outside, so many people are doing a lot of research work, in medical, that is Internet of Medical Things. So, but if you see the research community, only few people are working in this Internet of Military Things. So as a student, or maybe if you are interested, you can incline your technical knowledge in this direction as well. That is looking at IoT in a military and defense system. So that's why I call this as a niche domains in IoT. There is a one more domain, that is Internet of Underwater Things. So basically, Internet of Underwater Things is connecting. We understood what is Internet of Things. Internet of Underwater Things is basically connecting the underwater devices to Internet. So underwater devices in the sense you can connect submarines, sonars, and acoustic transceivers. So these are all the underwater objects or underwater things that can be connected to the internet. So some of the key areas which you can easily recognize, that is aquatic animal tracking and environmental monitoring, and even for defense system. But underwater is quite challenging. The reason is because the medium itself, it is challenging. As we know that you might have studied in school, right? So radio waves cannot penetrate inside a water molecule. But then imagine about the ocean or sea or deep ocean, for example. So then we need to use acoustics. So the fundamental physics is sound can travel faster in water. So again, you need to create all the subsystems, for acoustics. So these are all some of the challenges in underwater things. So this is actually a niche domain, and there is a growing interest in this area as well. So if you look at Dell Technologies statement about the potential of ML, right? So there, as I told you, there are lots of challenges because of the medium, especially for if you look at from a networking perspective, there is a challenge in terms of attaining a good quality of service. This quality of service is basically a networking terminology, and security, network security. So how you're going to protect your acoustic signals, detections, object tracking. So all this can be, mitigated with the integration of machine learning algorithms. That is what the potential of machine learning in Internet of Underwater Things. So my point is that suppose if you are interested and if you want to do any sort of applied machine learning research or study, so don't incline yourself to medical, like medical or other areas, because these are all the areas already so many people are working in. Uh, so these are some of the niche domains like Internet of Military Things and Internet of Underwater Things. So in this area, there are lots of challenges. So what you can do is you can apply the machine learning mechanisms in this context to enhance the existing systems, or otherwise to get some good performance out of it. So that is the potential of ML in Internet of Underwater Things. Okay, I think now the time is around 4:25. So yeah, so with this note, I would like to stop my talk. Yeah, that's all about the presentations.
So thank you so much, sir, for your valuable time, and we are looking forward for a few more classes. Uh, Thank you so much.